Hi everyone, I hope you are feeling well and keeping safe. My name is PEDRAM HAERI and this is my paper which is about data clustering based on the Chimp optimization algorithm. The content of my presentation is as follows. First of all, I want to talk about the details about data clustering task. The second part is about the Chimp optimization algorithm and how it is work. After that, I will introduce our purpose work and the application of Chimp optimization algorithm for the data clustering task. And finally, I will represent the statistical result of our purpose work, and it will be compared against some well-known and recent clustering techniques. Now we go to the introduction part, which is about the data clustering. If I want to talk about a little about this field, I can say there are two main types of tasks in the field of machine learning. Two main tasks, supervised learning and unsupervised learning. In the supervised learning, they use the label data to predict the output value. But on the other hand, unsupervised learning don't use the label data to predict the output value because it does not make any prior information about the data or the data object or about the label. Now I want to talk about a little about the data clustering task. Data clustering is a process of categorizing or grouping a set of data into different clusters or different groups. It should be noted that the data within a cluster must be extremely similar to each other, and on the other hand, the data out of the cluster or within different clusters must be highly dissimilar to each other. The similarity and this dissimilarity can be defined by the intra-cluster distances, which should be minimized to achieve the better clustering performance. Now, if I want to talk about why we use the optimization algorithm for data clustering task, it should be noted that the traditional clustering algorithm, although they are an effective strategy in a wide range of applications, but they are faced with some issues and limitations. The first issues and their limitation is that they are completely dependent on the initialization parameters. And the second one is that they are not appropriate for a large data set because they have a high computational cost and they are so complex algorithm. And finally, they cannot be an efficient method for grouping or clustering the set of data into a different cluster while our data set contains an overlapping area. Or to put it another word, it means our data set, the data points or data object of our data set so close to each other, and it means the data set contains an overlapping area. And what is the solution? The solution is that the clustering algorithms or the clustering problems can be assigned as an optimization problem, and our goal is to maximize or minimize our objective function. Now I want to talk about the second part, which is the Chimp optimization algorithm or ChOA. In recent years, several kinds of meta-heuristic optimization algorithms are proposed, and they are applied to solve different and various optimization problems such as feature selection and data clustering or other area. And finally, the important characteristics of meta-heuristic algorithms is first of all, they have a nonlinear objective function. Secondly, they can support a wide range of search domains, and they can employ to optimize the search space. And finally, they try to find the optimal solution in a reasonable amount of time. Chimp optimization algorithm is inspired by the social behavior of chimps, including their individual intelligence and sexual motivation while they are in hunting groups. A chimp colony or a chimp groups is a group of four kinds of chimps: attacker chimps, chaser chimps, barrier chimps, and driver chimps. And the attacker chimps, at the last stage of hunting process, they attack to the prey and they finish the hunting process. And the attacker chimps are the strongest chimps in the chimp colony. After that is a barrier chimps who construct a dam on the top of the tree and the chaser who is following the prey to catch up with it, and the final and the last kind of chimps is a driver who pursue the prey without catch up with it and look after the prey to don't lose it. And after that, chimps hunting process has two main important parts, namely exploration part and exploitation part. In the exploration part, it contains three parts: driving, chasing, and blocking the prey. And on the other hand, at the exploitation part, there are only the attacking and hunting prey. Chimps' behavior patterns generally include 5 independent parts, and these independent parts are mathematically formulated in the algorithm and prepare a chimps optimization algorithm. And they are include these 5 parts: exploration part, utilization part, driving and chasing part, exploration part, and finally social motivation part. And based on these 5 parts, we formulate our chimps optimization algorithm, and it can work like a meta-heuristic or optimization algorithm. Now I want to go to the third part, which is our purpose method. First of all, I should note that the main aim of our data clustering task is to partitioning n data samples into k clusters, where n indicates the number of samples, k shows the number of clusters, d represents the position of each sample, and c represents the position of each cluster center. Because for example, maybe our data clustering is in a 2-dimensional or in a 3-dimensional, and because of this reason we have a position about each sample or each cluster center. After that, the objective of, or the aim of our data clustering is to minimize the sum of the square Euclidean distances between each data sample and the cluster of each and the center of each cluster. And as you can see, this is objective function or fitness function can be defined according to the below equation, and you can see in this part. After that, the chimp optimization algorithm in our purpose method is suggested for solving data clustering problems. We can first of all, we should transfer the chimp optimization algorithm to a clustering based algorithm based on the encoding of candidate solution, and we need to encode the candidate solution. And because of this reason, we assign each chimps to represent the cluster solution, where the X attacker represent the best set of cluster centers, X chaser represent the second best set of cluster centers, and following that, barrier and driver represent the third best and fourth best. And because as I mentioned previously, the attacker chimps are the strongest chimps. And in the conclusion, you can see my flowchart of the purpose method, because you can become more familiar with this process. First of all, in this part we use the IRIS dataset as an initial data point or input. And after that, first of all we define our objective function, then initialize the random population of chimps, and after that we initialize the algorithm parameters, such as, because for example, like the other meta-heuristic algorithms, every algorithm like chimps has their own parameters and they need to be tuned. And chimps optimization algorithm include some parameters like f, a, c, r, and m. And after that, we input the rich dataset, then calculate the k-centroid for d data objects, and after that we calculate the position of chimps, and then divide randomly each chimps into the different group. After this part, which is the first part of our purpose method, after that we calculate the fitness of chimp and calculate the position of chimps, of each chimps. It means the F, which refer to the fitness value, and after that the X, which refer to the position of each chimp. After that we go to the chimp optimization algorithm, and it works and extract the chimps group, and it use them to update the parameters such as F, C, M, and finally calculate the R, A, and D. And the output of this part is the new fitness value and new position. After that, the chimp optimization algorithm compared the obtained fitness value with the previous fitness value, and finally it compared and find the best fitness value, which has a minimum amount of fitness value, because as I mentioned previously, our objective function should be minimized because the minimum intra-cluster distances is better performance for us. And finally it find the chimps with the minimum fitness value, and it consider this chimp as the best chimp, which is X attacker, and X attacker finally is our best cluster centroid, and assign each data object to the nearest cluster centroid. Now I want to talk about the experimental result, and we compare our purpose method against the other algorithm or other techniques. In this part, first of all, I should mention that we evaluate the performance of the purpose method based on or according to the two criteria. The first one is SICD result, and the second one is ER result. In the SIDC result, it's referred to the objective function, which I explained it in the previous part, and this is our objective function. And the second criteria is the ER value, which is the error rate, and it should be minimized to have a better performance. After that, in our purpose method, in our paper, we used 4 different clustering data sets, including risk, wine, cancer, and CMC. And as you can see, it has a number of clusters. You can see the number of features and the number of data objects. After that, the experimental results. In this part, we compared the performance of our purpose method against 6 other well-known algorithms such as K-means, Big Bang, gravital search, improve krill herd, PSO, and black hole. And as you can see, our purpose method achieved the best performance in terms of the SICD result among all of the algorithms, and it has the minimum SIDC result, or the minimum fitness value, and it means our purpose method is so stronger than the other. For the next evaluation criteria is the error rate, and you can see our purpose method represent the minimum error rate in terms of in this evaluation criteria among all of these algorithms, and it has a minimum value of the error rate. And finally, in order to prove the strength of our purpose method, we compare it against 6 recent clustering algorithms and a hybrid algorithm, because the hybrid algorithm is a very strong algorithm, and if we can defeat or achieve the better performance than the hybrid algorithm, it means our purpose method has a valuable performance. And as you can see in this part, our purpose method or chimp optimization algorithm data clustering task outperformed all of the algorithms, and it attained the minimum SICD result in terms of among all of the algorithms. And finally, I want to explain a conclusion part, and explain the main contribution of this paper. First of all, we're proposing a ChOA for solving data clustering problems. After that, our purpose method increased the data clustering efficiency, and after that, our purpose method reduced the number of misclassified data objects or decreased the ER value. Moreover, our purpose algorithm is so fast Also, it's not too complex, and finally, it requires a small number of parameters for tuning. Thank you so much for your listening. Thank you so much for consideration, and thank you so much for your time. If you have any question, I'm glad to hear. Thank you.